Hello students, I am Subhashish. In the previous lessons, we have learned arithmetic progression and geometric progression. In this session, we are going to learn about special series. Special series are those in which the sum can be expressed using explicit formulas. Therefore, these series are known as special series. Learning outcomes. After the completion of this lesson, you will be able to determine the sum of some finite series such as sum of n square, sum of n cube. To apply the concept of finding the sum of some finite series such as sum of n square, sum of n cube. Keywords from this lesson: numbers, series, sequence, terms, natural numbers, odd numbers, square numbers, cube numbers, first term, last term, common difference, sum. Children, here we study some common special series. Sum of first n natural numbers, sum of first n odd natural numbers, sum of squares of first n natural numbers, sum of cubes of first n natural numbers. We can derive the formula for the sum of any powers of first n natural numbers using the expression x plus 1 power k plus 1 minus x power k plus 1. That is to find 1 power k plus 2 power k plus 3 power k plus so on plus n power k. We can use the expression x plus 1 whole power k plus 1 minus x power k plus 1. Let us see some common special series formulas. The sum of first n natural numbers 1 plus 2 plus 3 so on plus n is equal to n into n plus 1 by 2. The sum of first n odd natural numbers 1 plus 3 plus 5 so on plus 2n minus 1 is equal to n square. The sum of squares of first n natural numbers 1 square plus 2 square plus 3 square plus so on plus n square is equal to n into n plus 1 into 2n plus 1 by 6. The sum of cubes of first n natural numbers 1 cube plus 2 cube plus 3 cube plus so on plus n cube is equal to n into n plus 1 by 2 whole square. Let us see one example. Find the value of 1 plus 2 plus 3 so on plus 50. Solution. Given 1 plus 2 plus 3 plus so on plus 50. By using formula 1 plus 2 plus 3 plus so on plus n is equal to n into n plus 1 by 2. Here n is equal to 50. By substituting in the formula, we get 50 into 50 plus 1 by 2, which is equal to 1275. Let us see one more example. Find the value of 16 plus 17 plus 18 plus so on 75. Solution. By using formula 1 plus 2 plus 3 plus so on plus n is equal to n into n plus 1 by 2. Here the equation can be written as 1 plus 2 plus 3 plus so on plus 75 minus 1 plus 2 plus 3 plus so on plus 15. Here n is equal to 75 for first series and n is equal to 15 for second series. By substituting n value in the equations, we get 75 into 75 plus 1 by 2 minus 15 into 15 plus 1 by 2. By solving them, we get 2850 minus 120. Now by subtracting, we get 2730. Let us see examples for sum of odd numbers. Find the sum of 1 plus 3 plus 5 plus so on up to 40 terms. Solution. 1 plus 3 plus 5 plus so on up to 40 terms. We know the sum of first n odd natural numbers is equal to n square. Here n is equal to 40, so n square is equal to 40 square, which is equal to 1600. Find the sum of 2 plus 4 plus 6 so on plus 80. Solution. Given 2 plus 4 plus 6 so on plus 80. By taking 2 common from the series, we get 2 into 1 plus 2 plus 3 plus so on plus 40. Here n is equal to 40. By substituting, we get 2 into 40 into 40 plus 1 whole divided by 2. By solving, we get 1640. Find the sum of 1 plus 3 plus 5 plus so on plus 55. Solution. Here the number of terms is not given. Now we have to find the number of terms using the formula n is equal to L minus A by D plus 1. Here L is equal to 50 and A is equal to 1, which gives n is equal to 55 minus 1 by 2 plus 1, which is equal to 28. We know the sum of first n odd natural numbers is equal to n square. Therefore, 1 plus 3 plus 5 plus so on plus 55 is equal to 28 square. By solving, we get 784. Let us see some examples for sum of square series. Find the sum of 1 square plus 2 square plus so on plus 19 square. Solution. Given 1 square plus 2 square plus so on 19 square. We know sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. Here n is equal to 19. By substituting n value, we get 19 into 19 plus 1 into 2 into 19 plus 1 by 6. By simplifying, we get 19 into 20 into 39 by 6. So, by solving, we get 2470. Find the sum of 5 square plus 10 square plus 15 square plus so on 105 square. Solution. Given 5 square plus 10 square plus 15 square plus so on plus 105 square. We know sum of squares of first n natural numbers is equal to n into n plus 1 into 2n plus 1 by 6. Now we take 5 common from the series. Then we get 5 square into 1 square plus 2 square plus so on plus 21 square. Here n is equal to 5 and by substituting we get 25 into 21 into 22 into 43 by 6. By solving, we get 82,775. Find the sum of 15 square plus 16 square plus 17 square so on plus 28 square. Solution. Given 15 square plus 16 square plus 17 square plus so on plus 28 square. The given series can be written as 1 square plus 2 square so on plus 28 square minus 1 square plus 2 square plus so on plus 14 square. We know the sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. Here n is equal to 28 in the first series and n is equal to 14 in the second series. By substituting n value, we get 28 into 29 into 57 by 6 minus 14 into 15 into 29 by 6. By simplifying, we get 7714 minus 1015. By subtracting, we get 6699. Let us see examples for sum of cube series. Find the sum of 1 cube plus 2 cube plus 3 cube so on plus 16 cube. Solution. Given 1 cube plus 2 cube plus 3 cube plus so on 16 cube. We know sum of cubes of first n natural numbers is equal to n into n plus 1 by 2 whole square. Here n is equal to 16. Substitute n value in the given formula, we get 16 into 16 plus 1 by 2 whole square, which is equal to 16 into 17 by 2 whole square. By simplifying, we get 136 whole square, which is equal to 18,496. Find the sum of 9 cube plus 10 cube so on plus 21 cube. Solution. Given 9 cube plus 10 cube plus so on plus 21 cube. The sum of cubes of first n natural numbers is equal to n into n plus 1 by 2 whole square. The given series we can write as 1 cube plus 2 cube plus 3 cube plus so on plus 21 cube minus 1 cube plus 2 cube plus 3 cube plus so on plus 8 cube. Here n is equal to 21 and n is equal to 8 in first and second series respectively. Substituting n value in the formula, we get 21 into 21 plus 1 by 2 whole square minus 8 into 8 plus 1 by 2 whole square, which is equal to 231 whole square minus 36 whole square. By simplifying, we get 52,065. Points to remember. The sum of first n natural numbers 1 plus 2 plus 3 so on plus n is equal to n into n plus 1 by 2. The sum of squares of first n natural numbers 1 square plus 2 square plus 3 square so on plus n square is equal to n into n plus 1 into 2n plus 1 by 6. The sum of cubes of first n natural numbers 1 cube plus 2 cube plus 3 cube plus so on plus n cube is equal to n into n plus 1 by 2 whole square. The sum of first n odd natural numbers 1 plus 3 plus 5 plus so on plus 2n minus 1 is equal to n square. Thanks for watching.